Hi, my name is Elad Jarby, and today I'm so proud to present to you my project in the Algorithmic Programming in Java course. The project was created by me. So let's begin. The algorithm that was used to create the maze is growing tree generator algorithm. We start with a list of cells, internally empty. After we add one cell to the list, at random, we choose a cell, call it C, from the list. If cell has unvisited neighbors, we choose an unvisited neighbor of cell, let's call it N. We create a passage from C to N by breaking the wall, and we add N to the list. Otherwise, we remove cell C from the list. We repeat steps 3 and 4 until the list is empty and finally the maze is created. On the course, we was requested to build two versions for growing tree generator algorithm. First, to choose the last cell from the list, and second, to choose randomly cell from the list. The algorithm that was used to solve the maze is best first search algorithm. We use priority queue and set of nodes. For each iteration, we remove from the priority queue the best node, put him inside the set, and check if we are in the goal position. If not, we create n successor. If the successor is not in the closed list and not in the priority queue, we update that we came to s from n and add s to the priority queue. Otherwise, if the new path has cost lower than the previous one, we check if he's not in the priority queue, so we add him to the queue. Otherwise, we adjust its priority. The general idea of best first search is avoid expanding paths that are already expensive by expanding the most promising node chosen according to a specific rule. And ultimately, we continue the path to the goal position with the best matching successor. Now we move to the Eclipse. As you can see, the structure of the server and the client is MVP, model, view and presenter. Now let's start a new server and two clients. Let's start the server. Server is open, number of clients to enter on the same time is 5. You can change all the settings on the properties window. You can change the port, the client's number you can enter on the same time, the timeout, and the view GUI or CLI. Now let's start a new maze. Hello, press generate maze, choose name, flow, width and length, choose axis Z, Y or X. Now let's generate a maze, call it demo, with 10 floor, 10 width and 10 length. You can move up floor and down floor, left and right, up and down, and ask for the server for a solution. When you get a request, he sends the solution back to the client. And now let's display the solution. Now we load another maze and solve it again. You can save the maze on a file. Let's call it demo2 and load the maze again. Now let's see some of the features of the maze. You can change all the settings on the properties window, the number of threads, the max size of the maze, the search algorithm BFS or DFS, the view, GUI or CLI, the algorithm, simple going last or going random, the server IP you need to connect to, and the server port. Now let's start the demo again. You can see your current position here. You can zoom in or zoom out the maze. You can change the perspective of the character and move on each perspective. You can get a hint for the goal position. Goal width is 7, goal length is 1, and goal floor is 6. Package has arrived, you win. Now let's move to CLI mode. You must restart the program before the new setting will take effect. Let's start the server again. Open server and a client. Generate 3D maze. Let's generate a maze that already exists. You can see maze demo is already exists. The maze is override and now is ready. Let's display the maze and get a solution and display the solution. If we ask for a solution again, you can see that the solution is already exists because we save all the solution in a cache file solution.zip. Now let's see what happened when we ask for a solution when the server is closed. Problem with the server, try to open server. Now let's exit from the client. You can see that all threads are closed. MVP is an architectural pattern that divides code to independent layers. The model is responsible for all the calculation, and the view is responsible for getting user requests and display the visual side for the user. The presenter is waiting for notification from view and the model to operate and link between view and model. So let's see how it works. The view and the model are both implementing observable and the presenter implement observer. First, the user sends a request to the view sends a notification to the presenter with the method notify observer. The presenter sends the command to the model runs all the calculation for the specific command, and when the model is done, it sends a notification back to the presenter. The presenter sends the command to the view, and the view displays the data to the user. Thank you for watching. See you next time.